Today we're going to start our study on different types of parent functions, and then we'll talk about transformations. So we're going to split this into two lessons. Today our focus will be on what the parent graphs are, and next time our focus will be on the transformations of these parent functions. So we're going to go through and go over each of the parent functions and talk about the domain, the range, x and y intercepts if they apply, and just the general equation for each of these parent functions. So we'll start with the linear function. So the linear function is y equals mx plus b. The domain of this function is all real values of x. The range is all real values of y. Now the x-intercept is when you set y equal to 0 and solve for x, and that gives you negative b over m. And then the y-intercept is where you set x equal to 0 and you get y is equal to b. Now, is it increasing or decreasing? Well, it depends on the slope of this linear function. So if it's a positive slope, it's going to be increasing. If it's a negative slope, it's going to be decreasing. Now, there are two particular linear functions that are special ones. And the first one is the constant function. So, for example, f of x equals 1. It doesn't have to equal 1. It could equal any other number, but it's the function where you have just a horizontal line and the slope is 0. It's neither positive or negative. It's constant. And then the second one is the identity function. This is the function y equals x. It's called the identity function because your x and y values are always going to be identical to each other. So for example, 1, 1, 0, 0, 4, 4, -3, -3. So those are all identical. The x and y values are identical to each other, and so we call this the identity function. Next up, we have the quadratic function. We've looked at this quite a bit already in this chapter, but the quadratic function, the parent function, is simply y equals x squared. The domain, so we can just look at this graph here. The domain is all real values of x, but the range is going to be just the values starting from 0 and higher. So all y values that are greater than or equal to 0. The x-intercept is at 0, 0, and it has a relative minimum value at 0, 0. Next is the cubic function. This is y equals x cubed. That's the general shape of the cubic function there. Now your x values, your domain, can be all real numbers. The range, in this case, unlike the quadratic function where it was everything from 0 and higher, the range in this case can be any real number as well. This also has an x-intercept at 0, 0. You'll notice that for these parent functions, a lot of them will have an x-intercept at 0, 0, a point at 0, 0, somewhere in there, because it is kind of the most basic form of the function. All right, and then this parent function is always increasing, so even though it's increasing at different rates, the entire function is still increasing overall. The next one is the square root function, so y equals the square root of x. Now, your domain, you'll notice for your values of x, it can be from 0 to anything higher than that, but nothing negative. Now that comes directly from the function itself. You can't have a negative under the square root. So the domain is all real values of x greater than or equal to 0. Now if you look at the range, you'll notice that the range is also going to be all real values that are greater than or equal to 0. The reason that is because anytime you take the square root of a number, you'll always end up having a positive value for y. The only exception is the square root of 0 is equal to 0, and 0 is the only non-positive value that will work. All right, so we have an x-intercept and a y-intercept at 0, 0. Next, we have the absolute value function. So y equals the absolute value of x. Now the domain for this, you can have any value for x. It can be positive, it can be negative. However, once you apply the absolute value onto the value of x to get your y value, you can only have values that are 0 or greater. So the range is all y values greater than or equal to 0. And then our x and y-intercept is at 0, 0. All right, the next function is the reciprocal function, and that is the function y equals 1 over x. Now, in terms of the domain, the only restriction you have is you can't have a 0 in the denominator. So in terms of your values of x, they can be any real number except for 0. Similarly, if you look at our graph here, the range can be anything except for 0. You'll notice that in both cases, the graph gets very, very close to, but never actually reaches 0. So you'll notice that this graph never actually touches the x-axis, and it also never actually touches the y-axis. So in terms of x-intercept and y-intercept, there are actually none because they never cross the x or y-axes. All right, the next function is what we call a step function. It's also known as the greatest integer function. Now the way that we write this one is y equals, and then we use brackets for x. What this function does is, if you take a look and see your x values, if you look from 0 to 1, all the values from 0 to 1 always round down to the nearest integer. So if, say for example, you have x is equal to 3.7, if you look at the graph, 3.7 gives you a y value of 3. So it always rounds down to the nearest integer. And so this is what ends up happening, and you can kind of see why it gets its name, the step function, because it looks like a set of steps going up. All right, so the domain is going to be, well, any value for x will work here. And then for the range, now the range is a little bit trickier here, but your y values can only ever equal integer values, because for every x value, you're always rounding down to the nearest integer. All right, and then in this particular case, we have an x and y-intercept at 0, 0. All right, we have one last parent function, and that is the cube root function. So that's y equals the cube root of x. And you'll notice this has some similarities to the cubic function, but instead of being long in the vertical direction, it is long in the horizontal direction. Now the domain is all real values of x. You can take the cube root of a positive or a negative value. The range is going to be all real values of y. Again, once you take the cube root of a positive value, it's positive. The cube root of a negative value is negative, so you can have values of y that are both positive and negative. And then we see that it crosses at 0, 0, so that is both the x and y-intercept. All right, so those are all the parent functions that we are going over today. And next time we will be talking about transformations on these functions. And so we should know all these parent functions very well so that we can work with these and then do transformations on these functions.